speaker series. My name is Christina Hamilton, the series director. Today we present a woman looking into the future, an artist and a designer of space exploration, Ariel Waldman. A big thank you to our partners today for their support: University Musical Society, the College of Engineering, the Decipher Conference, the Institute for Humanities, Design Corps Detroit, and Michigan Radio 91.7. A special welcome today to folks that are here with us that are UMS patrons and College of Engineering folks who attended the 50th anniversary screening of 2001, A Space Odyssey last week. And also to Decipher Conference attendees who are here in our midst from far and wide. You know, this moment of Ariel Waldman being here today was specifically designed as a keynote for this moment for both of these audiences and our regular STAMPS audience, as her work addresses the future of space, which inherently depends on design research. For those of you that are here that are joining us for the first time and you have no idea what the Penny Stamps is because you're coming with one of those groups, quick word of explanation: the Penny Stamp series is a program of the Stamp School of Art and Design, and it looks to present creators and innovators like our guest today as a way for our students to please connect, Christina. Connect directly with creative leaders from around the world and also with people in our midst, in our community. So we're here every week on Thursday at the Michigan Theater. It's always free, so you're welcome to join us anytime. We've got a great lineup of guests still to come, so you can grab a calendar in the lobby on your way out and plan to be here every Thursday. Next week, we will actually be hosting 2 special events in addition to our Thursday event here on the stage. So in addition to Thursday, you can catch us Wednesday here at the Michigan Theater at 5:30 p.m., where we'll be hosting a very special event with photographer, world-renowned fine art photographer, Catherine Opie, at 5:30 p.m. And then on Sunday, we will have a special event with Chinese artist Zhu Bing. This will be happening with a talk at UMA, that's the Museum of Art for folks not using that lingo, over on State Street. That begins at 4 o'clock. And then followed by that, you can walk over to the Michigan Theater. We'll have a big reception with food and hors d'oeuvres for you. And then you can see a screening of Zhu Bing's new film, Dragonfly Eyes. So that's 3 events next week, in addition to Thursday, when we will host Emory Douglas, the original Minister of Culture for the Black Panther Party. So, with all that said, today we're going to have a Q&A, which follows this presentation here. If you want to meet Ariel and you want to ask her some questions, just take a look, exit the theater, go to the left, down the hallway. There's another theater in the theater called the Screening Room. Join us there directly after this, and you can ask her some questions. I also just found out her book, which is a fantastic little book, is for sale in the lobby. We've got Nicola's Books here. And if you want to pick up a copy of her book and have it signed, then come and join us at the Q&A, and she'll sign it afterwards. And now, for a proper introduction of our guest today, I've invited one of our key partners today from the Decipher Conference. This conference itself is a one-of-a-kind thing, as it brings together diverse design communities looking for new ways of supporting through defining, doing, disseminating, teaching, and supporting research in the Americas. And it represents a whole variety of design disciplines. So please welcome the woman who conceived the conference itself, Stamps Assistant Professor Kelly Murdoch Kitt.
I was going to thank Christina, but she left too fast. When I came to my dean at the end of my first semester at Stamps and pitched my idea for an international design research conference, that was like 9 months ago, by the way. I'm sure some people thought that that was pretty out there. Maybe so, but I know it will be worth it. Well, I'm really honored to share the stage tonight with another woman who's also doing worthwhile things that are pretty out there. Like, way out there. Like, outer space. Ariel Waldman is a designer, and I'd say she's a self-made design researcher. She's a graphic designer who found her way to employment at NASA. That is cool. She'd probably be the first to tell you that she is not actually trained as a rocket scientist, but she has combined her passion for space exploration with her innate designerly sense that active participation in making things changes how we see and understand them. Using this approach, Ariel has not only envisioned new futures for space travel, but has brought space exploration down to Earth through innovations such as her ScienceHack Day. ScienceHack Day, for those who don't already know, engages the general population in science. Awesome! As well as the idea that thinking and learning through the process of making helps people come up with what she calls weird collisions, collaborations, and ideas. I know, you're thinking, I like her already. Yes, for her innovations in what she calls making science disruptively accessible, Ariel has been awarded grants from organizations like the Alfred P. Sloan Foundation, and in 2013, she received an honor from the White House for being a champion of change in citizen science. During the next 2 days of our Decipher Design Research Conference, we'll be having a lot of conversations about the role of research and design. For example, needing to conduct research in order to inform the things that we make, but hopefully also having a larger discussion that design research itself involves making things as a way of investigating possible futures. So I'm really thrilled to have as Decipher's opening keynote speaker, and a woman, as Christina described, who fulfills all these other amazing criteria, Kubrick fans, Stamps speaker attendees, this woman who totally gets it. Friends, let's give a warm Ann Arbor welcome to a design researcher who's truly out of this world, Ariel Waldman.
Thank you so much. Hello, it's my very first time in Michigan, so thank you all so much for having me here. So I wanted to start with this video here that I really love. And it might seem pretty simple at first. It's got these 4 little dots up here, but those 4 little dots are actually planets in a solar system that is not our own. This is an actual video of planets around another star that took place over 7 years. These planets are 129 light years away. They are in the constellation Pegasus, I believe. And to me, it's just mind-blowing that we are already living in a present day where we can get real movies of other planets in other star systems. It's just amazing. The way that we detect most of these exoplanets is also kind of amazing, because we are detecting them usually. We're not seeing them usually. That movie is really great, but we only really have images, and those very blurry types of images of exoplanets, maybe around a dozen or so, possibly up to 2 dozen. But the way that we detect these exoplanets for the majority is through the transit method, which is something where we look at a starlight, and when we see the brightness of that starlight dip down a very, very tiny percentage, we might actually be witnessing a planet passing in front of its star, and thus we might be seeing an exoplanet or extrasolar planet, or just a planet that's not in our own solar system. So the telescope that detects most of these exoplanets so far is the Kepler Space Telescope, one of my favorite space telescopes. I hope everyone has favorite space telescopes. But Kepler uses this method of looking at starlight very closely and looking for it to dip down in brightness so it can detect exoplanets. And the Kepler Space Telescope is really awesome, but I think it's also very aptly named. It's named after the astronomer Johannes Kepler, an astronomer that was around in the 1600s. And I like Kepler because in the early 1600s, he wrote potentially one of the very first works of science fiction called Somnium, or Dream. And in Somnium, he imagined what it would be like to have humans go to the moon, land on the moon, and conduct a lot of science on the moon, and also conduct science of how the Earth looks from the moon and be able to study the Earth from the moon. This was something that was pretty out there, if you forgive the pun, in the early 1600s. In fact, it was so out there that he dressed it up, I believe, as science fiction to avoid persecution. I think he had real aspirations for humans going to the moon and doing science there. But in the 1600s, that was also around the time of Galileo, who was famously persecuted for observing things like perhaps the Earth revolves around the sun and not the other way around. So Kepler's work of Somnium was 361 years before the first moon landing. 361 years, he imagined this dream of humans going to the moon and exploring there and doing a bunch of awesome science. So fast forward to the 1960s, when humans started going into space, when humans were on their way to the moon. And suddenly this dream that had taken 361 years in the making, in the 1960s, people started imagining it going exponentially. So not only were we going to be sending humans to the moon, but we were going to send the first spaceship on Venus. And not only that, going to the moon was not exotic enough. We had to send men inside the moon to do a bunch of exploration there. And then we had to journey to the sun, or journey to the seventh planet, which is Uranus. I can't imagine why they wouldn't put that in the title. And then in the 1960s, we imagined even farther. We imagined, what about going to the end of the universe? And this was a film that is said to be an inspiration for 2001: A Space Odyssey. And you can see a lot of similarities in it from a design perspective, a fairly minimalist sort of aesthetic. And so in 2001, you had this sort of cultural keystone moment for some. 2001 was this interesting film that hopefully all of you have now seen for the 50th anniversary. And it had all these very minimal qualities and primary colors. It had a very clear aesthetic. And in this way, I believe, because it was communicated so clearly with a very clear design aesthetic, a lot of people started imagining that this is what space exploration should be like, or this is what it will be like, or as we explore farther and farther, this is what space exploration is really going to look like. And so we see echoes of that to this day in movies like Interstellar and others, where we sort of see minimalist qualities, limited color palettes, and just very sleek sort of design aesthetics. And then this bleeds over into real life. So up here are spacesuit mock-ups from SpaceX and from Boeing. And as you can see with both, they're pretty minimalist qualities. The Boeing one takes sort of a hat tip from those primary colors. And I think the reason why a lot of these spacesuits and a lot of these things that we see in reality are sort of hearkening back to 2001, even though it was 50 years ago, is because I believe a lot of people feel the need to tap back into this idea of excitement that existed in the 1960s around space exploration. You'll often hear people talking about how there was a golden era of space exploration when everyone was really excited about it, and we were imagining farther and imagining all this stuff, and perhaps, maybe, we've lost our way. Or that's what some people at least believe. And so I think you see a lot of design aesthetics tapping back into the design aesthetics from 50 years ago because they believe perhaps they'll get some of that excitement back. But the reality is that when you look at the data, when you go back into public polling data, there's actually nothing that supports this idea that there was a golden era of space exploration when it comes to excitement. So this is a chart generated by the National Academy of Sciences Committee on Human Spaceflight. And you can see from the 1970s to the 2010s, the amount of people who say that they were very interested in space exploration. And yeah, there's some peaks and troughs, but for the most part, it's about the same. You don't see this big cliff that people are sort of falling off of from the tail end of the moon landings in the 1970s. It stays about the same. For lack of a better term, it's kind of lukewarm. Another chart here from the same committee shows, again, from the 1970s to the 2010s, the amount of people who say that the moon landing was worth it. So This is looking at people who say that the moon landing was worth it. And again, from the 1970s to today, actually, you see a trend where people are more favorable towards the moon landing as time goes on. And you see this in actually a lot of data around space exploration, that when things are present day, people are like, well, it's okay. But when they look back, they're like, oh, it was totally worth it. It was amazing. And you can probably begin to see that. I didn't include it in this chart, but you can probably begin to see that over the coming decades with the space shuttle as well. So, as I mentioned, those charts were created by the National Academy of Sciences Committee on the Future of Human Space Exploration, or Future of Human Spaceflight, rather. And this was a really interesting committee that I took part in. So this was something where Congress requested that the National Academy of Sciences look into, why do we send humans into space in the first place? Is there a reason? And if there is a reason, how do we make a sustainable human spaceflight program over the next several decades? And so the National Academy of Sciences is an interesting organization. It was started by Abraham Lincoln to be an independent source to comment on the nation's work in science. So this committee was convened also in an unusual way, because typically these committees have people who are very specific experts in the exact domain of the report. But since this looked at the future of human spaceflight and really wanted to look at what all the rationales were for human spaceflight, they recruited people from many different disciplines. So economists, historians, particle physics, they did have an astronaut, Secretary of Defense, and there was me. It was a very unusual experience for me, and I learned a lot over the course of the 2 years, where we actually listened to a bunch of public testimony, looked into historical polling data, took in a lot of surveys, and talked to as many people as we could about the future of human spaceflight. So for me, when I'm thinking about the future of human spaceflight, I like to also look at the past. So in 1969, we had a fairly historical event. America landed a human on the moon. But also in 1969, a lesser known but equally historical event took place. We sent the first message over ARPANET, the early form of the internet. And that message was LO for login, and the computer crashed shortly thereafter. But that said, 50 years later, only around 550 people have ever been in space. Meanwhile, nearly 3.5 billion people, or half the planet, are on the internet. So in a sense, this to me looks like space exploration is kind of broken. But that said, I know that space exploration isn't just about going into space. There's many ways to be involved in space exploration that don't involve actually going into space yourself. But again, 50 years later, I still have issues with a lot of the imagery and things that we're exposed to. So 2 images, 1969 moon landing, and 2018 SpaceX Falcon Heavy launch. And these images frustrate me because space exploration definitely needs to be more diverse and inclusive, extremely so. But also, these images frustrate me because they sort of gloss over the many different types of people who are involved in space exploration today. Around the world, at SpaceX, at NASA, there are many different people from many different backgrounds involved in space exploration, and we're still not really getting to their stories. So halfway between those 2 images, more or less, in 1990, this image was taken. How many of you are familiar with this image? Few of you. Okay, so this is one of my favorite images taken from another one of my favorite spacecrafts, Voyager I. And if you can see that tiny little speck of a pixel there, that's Earth as seen from about 4 billion miles away. So that's where you can find me if you need me. But the reason why I love images like these so much is because it shows us how space exploration often changes our view of ourselves and our place in the universe. But most of my work focuses on changing how we view space exploration. And I think it would be more accurately named space observation, because that's really the relationship that most of us have with space exploration. We're watching astronauts or government agencies or Elon Musk explore on behalf of us, but we ourselves aren't doing much exploring. And so this relates to my own personal story, because I was not involved in space or science or anything a few years ago. And I was at home watching a documentary called When We Left Earth. It was this great documentary about NASA during the early days and how they were trying to figure out how to send humans into space for the very first time. And I became so incredibly inspired by this documentary that I decided to send someone at NASA, someone I had never met, an email saying that I was a huge fan of what they were doing. And if they ever needed someone like me, someone completely without a science background, that I was here. It was a geeky piece of fan mail. And just to give you a little background on myself, so I went to art school, I got my degree in graphic design. Science and space weren't really something that it wasn't really a thing for me. Not that I disliked it or had anything against it, it just wasn't really on my radar. I was obsessed with design, and I still am today. And my ultimate goal as a little teenager was to be an executive creative director. As a very weird teenager. But to me, being an executive creative director was the ultimate goal, because to me, I was like, that's really the job where I can take design and just apply it to the whole world as my palette. I don't have to work on just brochures or websites. I can work on everything. That was in my head, at least. And so fast forward a few years, I was starting to feel like I was in a bit of a rut, because I was getting frustrated that my palette to work on as a graphic designer often was pretty limited. Again, brochures, websites, that sort of thing. And I was getting frustrated that I couldn't really apply design to as much of everything that I wanted to. So I had sent this geeky fangirl email to NASA, and really never expected to hear back. And serendipitously, I ended up getting a job at NASA from that email. And it completely changed my life, and I kind of felt like this. Did not expect for that to happen. I've probably sent out a lot of fan mail over the years that probably never got answered, but this one did, and I got this job at NASA, and it changed my life. And so I wanted to share with all of you a quick clip from this documentary that sort of better explains just what I found so inspiring about it in the first place.
To beat the Soviets, NASA must launch a man into Earth orbit. Only rockets can go fast enough.
We knew nothing about rocketry, we knew nothing about spacecraft, we knew nothing about orbits.
I saw a lot of rockets launched. I'd say that somewhere between 30 and 40% of them failed. A lot of them came up off the pad and went the opposite direction. Some of them got halfway off the pad and blew up. Some of them got to 10,000 feet and turned the other way and blew up.
The whole thing crumbled and blew up. It looked like an atomic bomb went off almost over our heads. We got a big kick out of watching the Mercury astronauts. It was great looking at their eyes. We're looking at this thing and looking at each other and deciding we want to go back and talk to the engineers a little more before we go further.
And so that's what I love so much about this documentary. It actually always reminds me of this image here. You heard them talking about how they didn't know anything about spacecrafts or rockets or orbitry or orbits. And I was watching this saying to myself, well, I don't know anything about space exploration, and I want to work at NASA. That sounds amazing. So I got that chance, and it really changed my perspective of NASA from being a bunch of rocket scientists to being a bunch of space hackers. That they were figuring things out as they went along, that they didn't know everything beforehand. They weren't this idea of rocket scientists that are experts before they do everything. They were having to figure it out and try as they went along. And so for me, getting this chance to work at NASA really changed my perspective and changed my relationship with space exploration. And it was really around the idea that doing something changes how you see it. So actually doing science and doing space exploration changes your relationship with it from something of observation to something of participation and contribution. And so I learned a lot of things while I worked at NASA. I learned that I don't need to be an astronaut in order to explore space. But even more importantly, I ended up learning that I didn't even need to work at NASA to explore space. And so I left. And I created SpaceHack.org, which is a directory of ways for anyone to participate in space exploration with or without a formal science background. This year is the 10-year anniversary of me launching SpaceHack.org. And it's really fascinating to me to see what's changed and what hasn't over the last even just 10 years in space exploration. So I built SpaceHack.org not as a way to build a bottle rocket in your own backyard. I'm sure it's a lot of fun, but that wasn't my motivation. I built SpaceHack.org because, well, I wanted people to be able to do space exploration on their own. I wanted people to send their teddy bears into space. This is actually a project that 11 to 13-year-old kids in the UK did several years ago. They wanted to test out how different materials react in space, but they can't afford a rocket launch, so they put them on a weather balloon and sent them to near space to at least do that sort of testing on those materials. And those are the sorts of things that I want to enable, people being able to do it themselves in a sense, but also collaborate with others and have really meaningful experiences. So 10 years ago, the problem to me really was that the history of NASA was really about kind of scrubbing away the personal stories of people who were involved in space exploration and people who went to space. And it sort of left space exploration feeling about as bland as the food that they send up there. No one was really represented, and I sort of understand why NASA did this and occasionally still does this to this day, because if no one's really represented up there, then maybe we can all imagine ourselves up there. But the problem with that for me is that we end up erasing or looking over a lot of these great personal stories of people who have been involved in space exploration. So I'm sure at this point, a lot of you have probably seen the movie Hidden Figures about Katherine Johnson and a number of computers and mathematicians involved in space exploration in the early days. And it's sad that it's not really until now that a lot of those stories are coming into focus and really getting the attention that they deserve. And there's so many other stories like this over the last several decades that we don't really know about. For instance, NASA really needed to use this certain type of honeycomb insulation on their Saturn V rockets, but they were really struggling with how to glue this insulation to the Saturn V rockets. And what they ended up discovering was that surfers use this type of material all the time. So for a short period of time, NASA hired surfers to work on the Saturn V rocket to actually get that insulation on it. And these are the stories that I love, but it's taken so much time to sort of get these out there. And now 10 years later, I feel like the pendulum has swung the opposite direction. Instead of having no one really represented up there, we have the problem where only one person is represented up there, or a select few billionaires are represented up there. And this creates the same problem, just in the opposite direction, that we have these cults of personality, and so we're having some stories out there, but again, it really obfuscates and goes over all of these stories of all the people who are involved in space exploration today, who have amazing stories and amazing things to share and really can help represent how multifaceted space exploration really is. And so you'll often hear these billionaires or titans of commercial space talk about, why do we go? Why do we go into space in the first place? What is the reason? And so if you listen to these billionaires and people who are at the very top in commercial space, they will often tell you that the reason why we go is for the survival of the human species. That the reason why we do this is because we need to be a multi-planet species, and if we are not, we're going to die out a lot sooner. And it's not necessarily that that's wrong or incorrect, but it's extremely misrepresentative. So again, to the National Academy of Science's Human Spaceflight Committee, we looked into why do we go? And we looked into public polling data and a lot of surveys, and we listened to public testimony. We did a lot of research over the past, the present, about why do we go? What is the reason? Is there one overwhelming reason why we send humans to space or why we explore space at all? And what we found was that there were many reasons. So we found, out of all of our research, we sort of distilled these rationales that people have into these categories of pragmatic rationales of science, economic benefits, international relations, inspiration of citizens and students, national security, but also aspirational rationales like human survival, and shared human destiny and aspiration to explore. And what we found was that people have many different reasons, and there's no overwhelming one reason why we explore. No one reason wins over a majority of people. In fact, most people will cite multiple reasons why we go to space if you ask them. And we didn't find anything in the data that said certain demographics like this one rationale and other demographics like this other rationale. No. But we did find that if you only have one rationale for why you're going into space, it's not a very good argument, because really so many people might disagree with it. In fact, it was the combination of pragmatic and aspirational rationales that really argued for a continuation of human spaceflight. And so, for me, I get really frustrated present day when you hear Elon Musk and Jeff Bezos and others talk about the reason why we do this is human survival. That's their reason. That's not the reason. And so again, it's not that those reasons are wrong, and it's not that I have a problem with people picking and choosing what reasons they have. The problem I have is when they say that this is the reason we're all doing this, because that's lying to you. It's misrepresentative of the multifaceted reality of what space exploration is about, and the fact that many people have many different reasons, and it's okay that we don't all agree. So I sort of want to go off script. I feel like space exploration has become scripted through science fiction and through billionaires and through a lot of things that end up reaching a lot of us in terms of how far the reach goes. And again, I like science fiction. I like 2001. I like commercial space. I like NASA. I like all of it. But the problem I have is that it feels like it's become scripted, like there's a one way to do this, and that there's a one way that it's going to look from a design aesthetic point of view. And so, to me, I want to break that apart and have something that's more representative of all of the different patchworks that are coming together and really making space exploration a reality. I want to essentially invent massively multiplayer science. And massively multiplayer science, to me, is something that brings people together from different disciplines and different backgrounds together to see what they can make, and where everyone is sort of being an equal player and contributing at a similar level. And this pulls from massively multiplayer online games, because I think there's a lot to learn from them. The fact that if you want to take down a big monster or accomplish a big task, if you have a pretty homogeneous group, you're probably not going to be very successful in your challenge. But if you have a group of people who have different backgrounds and different skill sets and different perspectives and different experiences in the game, and you bring them together, that's when a lot of times you can accomplish the big things like taking down a big monster or accomplishing a really big problem. So I want space exploration to look more like this, or versions of this, or many different things. I want to live in a present day where space exploration doesn't look like things that we've seen for many, many decades. I want to see new versions of it. I want to see the versions that often get hidden. I want to see all of the different ways to do space exploration. So I really love this project personally. This is called the Spacesuit Art Project that was started by astronaut Nicole Stott. And it's just amazing and sort of wackadoodle. And I love it because not only of the aesthetic, but also because of what it represents. This is actually a project that gets kids in hospitals from all around the world to contribute to designing these spacesuits. So up here on the right are kids from Pakistan, and on the left are kids from Houston, and they got people from many different countries to contribute to designing spacesuits, which is awesome. I also want to sort of live in a present day, where we send sculptures into space, but sculptures that are really fascinating. So this is a 3D printed sculpture that was a collaboration between Tokyo Art University and an engineering department and a number of hacker spaces. And this space probe was called ARTSAT-2. And ARTSAT-2 is cool not only because it's the only sculpture that's been sent into deep space, but also they programmed this space probe to be able to experience space, have a lot of sensors on it about what it's like in space, and actually generate poetry based on its experience in space and beam it back to Earth. And I just love things like this that are so massively collaborative and are really thoughtful. There's also other projects that I've come across that I love, where a group of researchers wanted to 3D scan supernovas. So supernovas are when a massive star dies and collapses and then it explodes out and it creates these really beautiful images, some of my favorite images in space. But they're typically 2D images. So they wanted to 3D scan a supernova, but you can't exactly take a 3D scanner and point it up at the sky and hope to get a 3D scan of a supernova that way. And you can't exactly shrink a supernova down and run it through an MRI machine and get a 3D scan of it that way. But in a sense, that's what these researchers did. They used an open source piece of software called 3D Slicer. And 3D Slicer is typically used to generate 3D fly-throughs of brain data. But they imagined, well, what if instead of feeding this piece of software brain data, what if we fed it supernova data? What if we fed it the supernova remnant Cassiopeia A? And the result that they got was this. This is the very first 3D fly-through of a supernova remnant that was ever created. And it was created through a project called the Harvard Astronomical Medicine Project. And as you can tell from the name, it got the astronomy department to collaborate with the medicine department and share visualization techniques and share different ways of doing design and different ways of solving problems. And it was beneficial on both sides. So in a sense, this sort of is an MRI of a supernova. And you would think these sorts of collaborations happen all the time. So obvious, just infuse a bit of serendipity into things and you get really great solutions. But I live in San Francisco and pretty close to Silicon Valley. And in San Francisco, Silicon Valley, Bay Area, we have all these amazing industries. This is an actual Google map of where NASA is and where Google is. They are literally right across the street from each other. And so you think there would be all this amazing collaboration between NASA and Google taking place because they're right next to each other. Or at the very least, there'd be a lot of social overlap. But a few years ago, I had friends from NASA who were taking a tour of Google. And they were walking around and looking around and going like, oh my God, we are at Google. They were so excited. And then I also heard from Google people who were like, there's NASA people here. Oh my God. And it was really cute, and they totally admire each other. So you would think there'd be all this great collaboration, but the reality is there's not. There's almost nothing. They don't collaborate hardly at all. There might be the tiniest of projects, but even then, it's very, very limited. You would think there'd just be all this stuff. And so, frustrated by this, I helped create an event called ScienceHack Day. And ScienceHack Day gets all sorts of people together, designers, developers, scientists, people from all different backgrounds, lawyers, roboticists, writers, you name it. Gets them all together in the same physical space to see what they can rapidly prototype with science in 24 consecutive hours. So the mission of ScienceHack Day is just to get excited and make things with science. They can be silly things, they can be serious things. We don't really care. We just care that you get excited and make something with science. And so I've had the great pleasure of visiting a lot of ScienceHack Days around the world. I've had the ability to go to Madagascar for their ScienceHack Day there, where they were working on smart chicken coops that were kind of like Internet of Things chicken coops. I went to Colombia, where they were working on making parks more accessible for the disabled. I went to China, where they were working on bio-inks and ways of doing weather-inspired jewelry. And ScienceHack Day is now in 29 countries all around the world, and anyone can create a ScienceHack Day in their city. So it's not a franchise, you don't need permission. It was developed to be open and grassroots. There are instructions for how you can create your own ScienceHack Day at sciencehackday.org, and it's really just taken off around the whole world. And I often get asked about if there's many differences between different countries, and if I can sort of notice different countries being interested in different things, or if some countries get it more than others. And the answer is no. People are geeky everywhere. People want to make weird, awesome, whimsical stuff with science everywhere, and it's just amazing to really see it grow. And so I wanted to share with all of you a few of the weird things that have come out of ScienceHack Day. This one is an example of a typeface someone wanted to create in which all the letters would have equal wind drag. So what you're looking at here is a makeshift wind tunnel, and someone cut out the letters of the alphabet, and then they recorded the wind drag of each individual letter and wanted to create this typeface. So if you need a typeface in which all the letters have equal wind drag, it looks something like this. I have no idea how this is useful at all, like none. But what I love about this is that this was a physicist named David Harris who was working on this, and he was working on typography. And this is what I love about ScienceHack Day, is that it's just as much for people coming and like playing around with science for the first time as it is for scientists playing around with design or playing around with technology or anything else for the first time as well. This physicist is actually now, I believe, on his way to getting a PhD in the arts. So it goes both directions, and I love that. This is another hack called Satellite Symphony, and you can type in your location anywhere around the Earth, and it'll tell you what satellites are currently overhead. But it'll also put those satellites to music based on how far away they are and how fast they're moving. And why I love this is because oftentimes when we're at school or work, you can sort of hear the traffic outside and get a sense for how congested or not it is outside. But we don't really have that same ambient awareness for space and how crowded or not it is over your head at any given time. So in a sense, that's what Satellite Symphony looks into. One of my favorite hacks has been a device someone wanted to create to detect when they needed to shave, essentially a beard detector. And so what this person did is they took a USB microscope, they got an image of the stubble on their face, and then they used an open computer vision library and wrote some very basic code. And as you can see, it's trying to draw the lines around the stubble on his face and saying, no beard found, no beard found. And then when it finds stubble, it'll tell him how long it is, and it'll tell him when he needs to shave. I had no idea what this had to do with science when I saw this, but we leave ScienceHack Day open-ended on purpose, and sitting in the audience and seeing this hack demoed was a particle physicist who thought it was actually a genius way for how to detect cosmic rays in a cloud chamber, which sounds ridiculous until you know what cosmic rays in a cloud chamber look like. And so following ScienceHack Day, this particle physicist ended up creating this multi-year student-led research program around detecting cosmic rays in a cloud chamber based on the original code and open computer vision library someone used to detect whether or not they needed to shave. And this is what I love about ScienceHack Day and prototyping through design and design and hacking in general is really it's about creating sparks for future ideas, future collaborations, and future cool stuff. here are some of the experiences from ScienceHack Day, and if you excuse me, I'll just look up at the screen to read it off. So one of the people who participated in ScienceHack Day said that ScienceHack Day introduced to me as a designer, for the first time, people who worked for NASA. It was a small revelation, even as an adult. These heroes of my childhood were just normal people. They were not magicians, unicorns, or untouchables. They loved geeking out on space as much as I did. ScienceHack Day introduced me to a community of scientific professionals who treated me, a non-scientist, as an equal. And I think we just need to have a lot more experiences like this, where people are getting together from these different disciplines and can have that sort of reaction and experience across both sides. And so I also work on an interesting program. Years after leaving NASA, I was invited back to NASA for an interesting program called NASA Innovative Advanced Concepts. And this is an interesting program because of what it funds. So the things that it funds are things like this. This is a project someone developed using computer vision of how the sunlight moves across the moon. And using computer vision, they're trying to make a route for a rover to stay in continuous sunlight. So in this video, essentially this little rover is treating shadows like lava. It can't touch it. And this is really useful, actually, because typically when you send rovers to the moon, they have to power down overnight. They don't have the solar energy. And so this is a project to actually keep rovers in continuous sunlight so they don't have to power down overnight. If you're familiar with computer vision, this is a fairly basic concept. It's very present-day tech, but it's transformative to the future of space exploration. And this is the thing that I am trying to help many people around the world and here in this audience realize, is that if you work in a discipline outside of space exploration, your existing present-day research and work can be very transformative if applied towards the future of space exploration. It can really change the game. And this is why I think multidisciplinary collaboration is so important. So, as I mentioned, this program, which gets shortened to Nyack, is a program out of NASA that funds the more futuristic sci-fi out there, transformative concepts that could go on to transform space exploration 20, 30, 40 years down the line. Things that you can do credible research into today, but maybe not possible still for a number of decades. And so this program is fascinating because they take in ideas from everywhere. So you can apply if you are working out of your garage, you can apply as a student, you can apply with no affiliation, you can apply essentially as yourself. You can actually submit to this program different ideas that could be helpful for the future of space exploration across both human and robotic and everything. And all they require is a 3-page white paper to apply. If this is something that is interesting to you or to people you know, the next solicitation would open up in August of next year, so you have more than enough time to plan for it. But you can go to nyackfellows.org and you can see sort of what it takes to apply. So similar projects that I've come across that I really like are, there was a competition on detecting dark matter and detecting the effects of dark matter more accurately, because dark matter is something that when we look at galaxies and we see that they're held together, we can't actually see enough mass to account for enough gravity to explain why they're held together. So we give this sort of the term dark matter. We don't know what's holding these galaxies together. And dark matter isn't uniform, it's globular. And so while we can't actually see dark matter, we can see the effects of it. And so there was a competition to better detect the effects of dark matter, to build better algorithms for it. And I like dark matter because dark matter to me reminds me that we are in a very friendly universe. We have all this invisible stuff that's helping us keep us all together and keep us all close and friendly, and it's great. But this competition had a participant that created a really unique way of detecting dark matter that beat out all the other algorithms. What this participant did is he actually looked at satellite data from, of glaciers, because he was a glaciologist. And he often looked at satellite data of glaciers to detect the edges of glaciers. And so he used his existing algorithms for detecting the edges of glaciers in satellite data and applied it to detecting the effects of dark matter, and it beat out all the existing algorithms to that date. Going back to Nyack and projects from Nyack, one of my favorites is a project that has microbes that poop out copper. Essentially, someone is working on synthetically designing microbes that can chew up spent electronics, so electronics that no longer work, and poop out copper. And so you could create new electronics with them. This is something that's actually really useful here on Earth, but especially useful in space where you can't really throw things away, or it's not a really good idea to just throw things away. You really need to recycle as much as you can. And so you would typically think that an idea for how to fix that would come from the electronics industry, but this idea is actually coming from a synthetic biologist named Lynn Rothschild. Another project that Lynn Rothschild and many others worked on is a project that looked at the microbes that are on the surface of the Earth in many different locations. Looked at microbes that were on the surface of the Earth in oyster ponds and deserts and many other locations, and cataloged the size and shape of those microbes, but also importantly, the color of those microbes. And the reason why she did this was because one day soon, we will eventually get images of exoplanets. Soon, relatively speaking, maybe not next year, but it could happen in our lifetimes. And when we get better images of exoplanets, better than the ones that I started this talk with, better than those little pixelated ones where we can actually see the color of those exoplanets, we'll sort of need an alien Pantone guide to sort of hold up to those planets and be like, well, that color could be produced by this certain type of microbe that we know of here on Earth. And I love this idea of creating essentially an alien Pantone guide, because I think it's something that designers can do, and it really illustrates how people from all different disciplines can get involved in the search for life elsewhere in space. And it's something where I believe we need a lot of designers to get involved in because of things like this that are up and coming, and we need different ways of detecting life, because there's no set way, and NASA hasn't fully figured out, nor has anyone else, how to fully detect life on other planets. So this is something that I'm increasingly getting involved with myself. I just got back a couple weeks ago from a 3-week ocean expedition where we were studying an underwater volcano off the coast of Hawaii. And this underwater volcano is thought to be an analog or similar to Enceladus, an icy moon of Saturn that has an ocean beneath its ice. And we don't know if it has any life there, but it could, because we've spotted hydrothermal activity on it. And so we were looking at this underwater volcano as sort of a similar area to detecting life around a moon of Saturn. And so this ocean expedition was amazing because it was multidisciplinary, and people were coming in from many different backgrounds to get involved in it. And while my expedition itself came to a close a couple of weeks ago, this ship is actually still exploring the ocean in many different locations, and it can be really informative to how we might one day detect life elsewhere in our solar system. So if you want to tune in to people doing deep sea research in real time and look at what mission control looks like on a ship and see what these underwater robots are that they're using to explore the ocean floor, you can go to nautiluslive.org. They are streaming 24/7 between now and mid-November, and it's a really cool thing to be able to actually see people do this research in real time and see them trying to figure out what all the things they're looking at are in real time. And they don't know, but they get really excited, and it's a lot of fun just to tune into. But my next project, so in 4 weeks from now, I'm going to Antarctica, which is really weird, and something I've worked a number of years towards going to. And Antarctica, to me, is like going to space. It's so remote, and it has so many similarities to space, and it's something that I'm really looking forward to. And if you want to follow along, I have a Patreon you can go to. Importantly, if you want me to send you a postcard from Antarctica, That link, I will send you one. I'm not joking. I will actually send you a postcard from Antarctica, so you can go to that URL. But Antarctica is really fascinating to me because I do a lot of things like this, which is capturing tardigrades in my own backyard. How many of you are familiar with tardigrades? A lot of you. Great, cool. So tardigrades are, these little microbes, and they have claws, and they're adorable. And this is one I scooped up from my own backyard. And so I am going to Antarctica to do video microscopy of all of the life that lives beneath the ice there, to better understand how life can exist in extreme environments. So that's a lot of life as we know it. But I also get asked a lot about life as we don't know it, life that maybe is nothing like here on Earth. And this is relevant for a few reasons. There's many other star systems and planets outside of our solar system, but in our solar system, it's also relevant because there is a moon called Titan around Saturn, which has lakes of methane and ethane. Essentially, there's no liquid water there, and it's really strange. It has like static electric sand, really weird weather, but if anything is living there, it's likely going to be life as we don't know it. So a group of astronomers teamed up with chemical engineers to imagine, well, what could life be like on Titan if it's not based off of water, liquid water? And what they imagined was this. This is a prototype of a cell membrane that's based off of nitrogen that they developed. And I think this is really cool, this idea that we can imagine life as we don't know it. But I think if we're at the point where we are already imagining life as we don't know it, I think we can imagine what exploration as we don't know it would be like. Exploration that is multifaceted, that's a patchwork, exploration that doesn't match up to a lot of the images that we've seen over the years, a lot of the design aesthetics that we've seen over the years, exploration that really represents just how much there is out there and how many different perspectives people have and different ways of exploring. When it comes to science fiction and billionaires and all these other things that we're exposed to, it's great that they can help light a pathway for us, but I don't think that pathway should be used as a gatekeeper, unless, of course, you're Stargate, in which case you sort of have to literally be a gatekeeper. But But it shouldn't be a gatekeeper to saying who can explore, how to explore, why we explore, or any of that. There should be many different reasons, and we should be okay with not having just one. And so, to me, I want space exploration that is more nebulous and hard to define, and perhaps just kind of murky because there's a lot of different perspectives and ideas being tossed into it. And with that in mind, I think this quote from John Peel says it best.
I mean, I think at the heart of anything that's good, there should be something, there should be a kernel or something that's indefinable. And I think if you can define it, or claim to be able to define it, then in a sense you've missed the point.
Thank you.